Good afternoon, everyone. My name is Lianping. I'm from Sun Yat-sen University in Guangzhou City. It's in southern China. I will present my thanks. Many thanks to the invitation of the IPK, and also many thanks to Professor Shu-Ying Jiang, and also a lot of support from her colleagues like Lee Nobeka or Zian, and because I just got my visa the day before my trip, so it's my first time here, and I very happy to share my work recently. Just done. My team research interests focus on the rational use of antibiotics among the residents, among the physicians, and also in the hospitals. So like development interventions to reduce overuse of antibiotics and evaluate the effect, the cost effectiveness, cost utility, something like that. The other work is about the antibiotic resistance and the factors like environmental factors, climate change, and today here, I would present some backgrounds and 3 studies. One is about the ecological association, and the 2 is we try to identify the causal effect of the ambient temperature on antibiotic resistance and some relevant conclusions. So we all know that antibiotic resistance is widespread and growing, and the problem is the most urgent health threat of our time, one of the most. And according to data monitored by the WHO, the Escherichia coli, the very familiar kind of a pathogen. Now the situation of antibiotic resistance is extreme heavy concern, and especially for China, you know, we have a large population, and we also the #1 of the antibiotic produce and use. And according to the math, we measure the emission of antibiotics is also very severe, especially in the southeast part of China. Some background, very briefly. Antibiotic resistance, longer hospital stay and higher medical costs and increased mortality. So according to the calculation from the IHME, from the University of Washington, the deaths in 2019 is about 1.27 million, and 929,000 deaths. And because the climate change, within this kind of background, antibiotic resistance is likely to develop over a certain period of time after repeat exposure to the warmer ambient temperature. So this kind of relationship, we also can. Okay, there are several studies review this kind of relationship. Back into the 2018, there's a global study. They combine a climate index, including the temperature and the precipitation. But the correlation is not significant. But later on, we can see the empirical study from the US and from the European countries. They showed the significant correlation between the antibiotic resistance to Escherichia coli and the lowest temperature in the US. And also the average minimum temperature and the AMR in 28 European countries. So this kind of association have some implication to this kind of to global health threat. But how is the situation in China? Because there's no studies, no empirical research. So we did a lot of work on this topic. Okay, first one is just published in the December 2022 in Lancet Regional Health. We start to explore the association between the antibiotic resistance and increasing ambient temperature in China using a nationwide panel data. The data source is from the ChinaNet. We call the China Antimicrobial Surveillance Network. This network is led by Huashan Hospital, affiliated to Fudan University. It's like some kind of the research lead working level. And the meteorological data and the social economic data is from the China Statistical Yearbook. And the variable we are interested in is the prevalence of antibiotic resistance. And the independent variable we focus on the ambient temperature. And there's also a lot of other confounders, include the DDDs, the usage of the antibiotics, and the CPI, the government corruption index, and the population density and GDP health resources indicators, a lot of them. So we use the statistical analysis method to measure the prevalence of AMR, especially for CRAB, CRKP, and CRPA, because this kind of resistant pathogen is the top priority all over the world, especially seriously in China. Independent variables focus on ambient temperature. We measure in two indicators. One is EQ1 is the annual average ambient temperature. Then EQ2 is year-by-year change in average ambient temperature, because we want to see the change of the year temperature, how long would be the, have largest impact on the AMR. So details are shown in the table 2, the right-hand side. And the confounders include a lot, like I said, the DDDS, CPI, and the GPP, and also a lot of the, the antibiotic use age is the factors related to the hospital, related to the hospital bed. And we also controlled for the other important meteorological factor like humidity and rainfall. Also, the method we used have two models. One is to test the effect of average ambient temperature. The other is to test the long-term accumulative effect of the climate change. Okay. So about the descriptive, the analysis of antibiotic resistance in China, we can see here for CRAB and CRKB, KP is a clear upward trend in China, but for the CRPA show a slightly downward trend. And we can see, because we draw this picture according to the average temperature. So the color is darker is the higher temperature. So higher prevalence of AMR have a higher average ambient temperature. So this kind of relationship is the guy we did the more the model running later. So it's a very easy, ecological analysis, and the calculation show that the number is the p-value is very significant. Prevalence of CRKP and CRPA increased with the rise of average temperature in China. But for the CRAB, there's no such significant correlations. And we also explored more factors associated with this kind of relationship. And the higher antibiotic consumption, lower health facility density, and higher hospital bed density, and also the government construction in the drug area also have a very significant impact on this kind of ecological association. And furthermore, we also, because the climate warming have a different impact in the different area, so we divide the sample in the northern China and the southern China, and we see the different the correlation, positive association between the ambient temperature and the prevalence of antibiotic resistance is shown in the northern part. But the negative association between the ambient temperature of prevalence of CRAB and CRKP were found in southern. Furthermore, we are interested in the cumulative effect of ambient temperature. Sorry, there's a mistake here. Changes in average ambient temperature show an accumulative effect. The RR is 1.09, is very significant. But average ambient temperature remained a significant stable predictor for both CRKP and CRPA. So some conclusion from this ecological nationwide study, because in China, we know we have a large population. So on the population level, the antibiotic resistance prevalence increased with higher regional ambient temperature. And this finding is similar to that in the European countries and also in the US. But the variation exists among the bacteria because different kinds of pathogens and the pathogen drug resistance is different. And we also find that year-by-year changes in ambient temperature have an accumulative effect on antibiotic resistance. And also, in China, the data show that the 4-year sum having the greatest effect. So, in light of the global warming and climate change, we have to, prepare for a long-term fight against antibiotics. If you only focus on the use, reducing the antibiotic overuse, for lower use of the antibiotics may be far slower than we expect due to the effect of climate warming. So this is the kind of some implications. Then we use another data set and try to identify the causal effect using difference in differences approach estimating. This work is just published in June 2023. The introduction I will go through very briefly. And in this study, we'll focus on the E. coli. Because E. coli, is very common, and a lot of the hospital infection happen. I will show a little methodological how we conducted this study. Because generally, because the factors may have interact with each other comprehensively. So we had to focus on the change of the temperature in the regional level. Indicity is on the provincial level, and we have the AMR rate in every province of China, and we set up the dominant variable for each year and each province to control the geographical differences. So we also adjust for the functions of the humidity and precipitation, because this kind of meteorological factor also, very important besides the temperature. So association between the AMR and ambient temperature use this CRSS database, because this database is led by the Chinese government, Ministry of Health. So every 1 Celsius degree increase in ambient temperature was associated with a rise of 2.71% for the 3G CREC. It's equalized for its resistance to third generation cephalosporins, and the other is the CREC and QREC. All of the result with the details is shown in the table. It's very significant. And we also, to predict based on given the precipitation and humidity, to estimate how the temperature change would affect the AMR. And with the median precipitation, like 800 millimeters, and the median relative humidity, like 64%, 1 Celsius degree the increase in ambient temperature was associated with an increase of 2.32% for the 3G CREC. And also for the CREC and QREC is also significant. You may ask a question, this kind of association maybe just not linear, right? So we do the other models to see how is the nonlinear association between the ambient temperature and the AMR. And the result shows that the association between the ambient temperature and AMR was linear for 3G CREC. But this kind of association is not, not shown in other two kinds of resistant pathogens. And the effect of the rising ambient temperature on the increase of AMR was more profound at a lower range of temperature. We can see the figures. When the temperature is lower, the association response is larger. So there's also other, deeper exploration about the increase in ambient temperature under the 10th and the 19th percentiles of socio-economic indicators. So we can see in this table about the expenditure, about the health resources. When the income increased, expenditure increased, or the hospitalization rate increased, there are significant effects of ambient temperature on the prevalence of the 3G CREC, and also the density of the health workers, the health bags, and the nurses, physicians. So according to these empirical studies, we can see that effect of increasing ambient temperature on AMR varies by different target, okay, different target of drug or bacterial species, and varies by the humidity and precipitation. And this study has another implication is about the socio-economic factors. It seems like that the association between the rising ambient temperature and AMR was more profound in regions with lower socio-economic status. But I had to mention, all of these are just, the sample from China. We don't know other, South or South Asia countries. Yeah, and increasingly, policy attention should be paid to the socio-economic disadvantaged region. And the study 3 is looking into the K pneumonia. They also use the data set from CARSS led by the Chinese government. And this study also just published in July 2023. So I will not go through all the details, because if you are interested, you can check the paper. Focus on new K pneumonia is also because our team work with the doctors from the respiratory department, and they have a strong feeling about this kind of problem. It's really should be concerned. So the data also point out here, the resistance rate is about 73.9% on average. So it's it's very high. We focus on two kind of resistant K pneumonia, 3GC RKP and the CRKP, also across the 31 provinces of China. And the variable is saying, and the details of the methodological. And also, we use standard DID design, set the province and the year time as the dominant variable to control the, to control the change impact. So for the 3G CRKP and CRKP, we can see the distribution in China. From 2014 to 2020, the prevalence of the 3G CRKP was higher than the CRKP. And we can see a detection rate of 3G CRKP exists a declining trend, and the trend is significant. And the detection rate of CRKP show an upward trend. So this is the different change trend. And in this study, we going to deeper to explore the lag effect of area temperature. And the lag effect temperature, you can see for the 3G CRKP is very significant. For every 1 Celsius degree increase in the annual average temperature, the rate of 3G CRKP increased by 4.7%. And every summer, we also divide the sample to see how is the relationship will be different in summertime or in the winter time, because we know the temperature change may be more high in different area. So the average summer temperature was positively associated. And furthermore, we also care about the socio-economic factors. And this study about the K pneumonia, the findings show that the higher economic status have a very different impact. On the one aspect, strengthens the positive association between the temperature and the 3G CRKP detection rate, but in the other side, weakens the positive association between the temperature and CRKP detection rate. So we still don't know why, but this is the model tell us. So some conclusion about the K pneumonia. Higher average ambient temperature was associated with a higher rate of this kind of antibiotic resistance. And also social-economic status may moderate associations. And for the carbon penance, this kind of antibiotics now is the name as the reserve line of the according to no matter in the WHO recommendation or just our in Chinese formulary, but this antibiotic resistance situation is very severe. So policymakers to recognize and address the impact of a high temperature and global warming on the spread of this kind of antibiotic resistance is very important. And tackling the important issues of social economic inequalities also should be concerned in this kind of relation. When you develop an intervention within the antibiotic stewardship. My research team, one side, in other area also have conducted a lot of work about the extreme temperature on infectious diseases like infectious diarrhea, basically dysentery, and also about extreme rainfall and flooding and the other kind of extreme weather event. That's all. Thank you very much.
Thank you, Professor Yang. AMR is one of the greatest global health issue affected by the climate change probably. So I think Professor Yang's study will be the first steps that we can go for more. Since we have a last speaker already online, maybe the questions for Professor Yang can be preserved for the break. So thank you.
Thank you.